Good day, students. Today, I want to talk on dimensions of physical quantity. Physical quantity simply implies on the way it is related, associated, or connected to the fundamental quantities. The method of dimensions can be used to find the relationship between quantities when mathematics is too difficult. It has been extensively used in hydrodynamics to show that the formula is correct or homogeneous. For example, capital M is used to stand for mass, capital L for length, capital T for time, capital K for temperature, capital A for electric current. Now let's start solving a problem. Start with work. Formula for work is force times distance. We don't know force. Force equals mass times acceleration. We don't know acceleration. Don't forget acceleration is velocity over time. We still continue. We don't know velocity. Break it down. Velocity equals displacement over time. Speed is distance over time. The difference between velocity and speed is that velocity is a scalar, is a vector quantity. Velocity is a vector quantity. Vector quantity means that it has both magnitude and direction. For example, when you say a boy moves 5 meters per second due east, that is referring to velocity because it has direction. Direction is due east. But when you say a boy moves 5 meters per second without telling us the direction, is referring to speed, which is a scalar quantity. You know that the unit of velocity is meter per second. Likewise, speed is in meter per second. The only difference that velocity is a vector quantity while speed is a scalar quantity. Okay, now from here you can now get the displacement is referring to length, the distance, displacement L over T. Displacement is a vector quantity that has direction. When you say the boy moves 5 meters due east, that 5 meters is a distance, but when you add due east, it has turned to displacement because it has direction. But it's referring to length, which is a space. Now L times 1 over T, we are trying to separate. There's 1 here, 1 times L will give us L. We are trying to separate it. Now L in indices 1 over T turn to L T raised power minus 1. That's for velocity. We now come to acceleration. Is that okay? No, this is velocity. Now come to acceleration. Acceleration now equals, you take your velocity, which is L T raised power minus 1 over the T. You now turn to L T raised power minus 1 times 1 over T. Try to separate it. Now to acceleration equals L T raised power minus 1 times T raised power minus 1 equals L T raised power minus 1 plus minus 1. Minus 1 plus minus 1 is minus 2. Don't forget, when you are owing somebody 1 naira, your 100 person 1 naira, how much are you owing together? That is 2 naira. Negative telling us that a sign of owing. Now L T raised power minus 2. That's our acceleration. Now come back to here, which is force equals MA, capital M, joining with LT raised power minus 2. That's our force. Okay, you have the A, we have the M, you join them together. Now you can now come back to our work. Work equals to force times distance, M, L, T raised power minus 2 multiplied by L. Work now equals ML times L. Bring them together times T raised to power minus 2. You have ML squared T raised to power minus 2. That's for work. Okay, now let's go to number 2, which is power. Power equals work over time. What's our work? We have gotten the work to be ML squared T raised to power minus 2 over T. Turn to ML squared T raised to power minus 2 times 1 over T equals ML squared T raised to power minus 2 T raised to power minus 1. We now have power to be ML squared T raised to power minus 2 plus minus 1 equals ML squared T raised to power minus 2 minus 1, that's minus 3. That's power. Okay, now the third one is the speed. Speed equals distance over time. Distance, use L to represent it over T. From there, just separate it. L times 1 over T, so L times T raised to power minus 1 equals to L T raised to power minus 1, the same as this velocity. You can see they are the same dimension. Now we have gotten work, power, speed, velocity is already there. Let's label it velocity. That's from our figure 4. I've done that. Velocity. Acceleration. I've done linear acceleration from our figure 5. Force. Have we done force? This force when you join mass and the mass capital M with acceleration that we got here. Join them. That's Roman figure 6. Roman figure 7. Pressure. Pressure equals to force over area. What's force? We've gotten force. Is our force, which is Roman figure 4. Roman figure 6. Force, which is ML T raised to power minus 2 over area, length times length, L squared. L cancel L. You have M T raised to power minus 2 multiplied by 1 over L, separate it, equals M T raised to power minus 2 times L raised to power minus 1. Let L come before T, equals M L raised to power minus 1 T raised to power minus 2. Okay, that's Roman figure 7. We're on Roman figure 8. That is momentum. Momentum is mass times velocity. What's our mass? We use capital M to represent mass. Multiply by what's our velocity? We got it somewhere. Velocity LT raised to power minus 1, which is ML T raised to power minus 1. That is our momentum. Let's go to impulse, Roman figure 9. Impulse. Impulse, we use capital I to represent it. It's force times time. What's our force in this case? we have force to be L t raised to the power minus 2 multiplied by time, which is L t raised to the power minus 2 plus 1 times is plus 1. From there you have L t raised to the power minus 2 plus 1. You are owing somebody 2 naira and you have 1 naira. When you pay the 1 naira back, remain minus 1, negative 1. That is that t raised to the power minus 1. Now we have moments. Roman figure 10. Moments. Moment is force times distance. What are force? We have force to be L t raised to the power minus 2 multiplied by L. When you have L times L squared. Okay, let's write it very well. L times L, we bring it together, t raised times t raised to the power minus 2. In indices, you have L 1 plus 1 in times it will be plus t raised to the power minus 2, which is L squared t raised to the power minus 2. Okay, that's for moments. Let's go to density. Now figure 11. Density is a mass over volume, capital M over L cube, which is capital M times 1 over L cube. Now capital M, L is power minus 3. When you read it off, turn to minus 3. Is for your density. Now let's go to electric charge. Figure 12. Electric charge Q equals to IT. You use A to stand for current, T, you see, AT. Now that one is capacitance. Don't forget that that's Roman figure 13. Capacitance Q equal to CV multiplied by V. You cancel V. Now you have C equals Q over V. And in power, don't forget that we have power. We have looked for power before. Your power equals to IV. Now from there you can get V. From there V equals to power over I, which is what's our power? Power is M L squared t raised to the power minus 2 t raised to the power minus 1 over A. Now you can see electric potential. You have to get electric potential before this. You have M L squared t raised to the power minus 2 t raised to the power minus 1. You can make it t raised to the power minus 2 t raised to the power minus 2 plus minus 1. A will go up, turn to minus 1. You have M L squared minus 2 plus minus 1. Owing somebody 2 naira, owing another person 1 naira. How much are you owing? You have t raised to the power minus 3, a raised to the power minus 1. Since that's the for electric potential, that one solve the problem of Roman figure 14. That one stands for the Roman figure 14. Okay. Now Roman figure 13, we got it from there. C equals, what's our Q? We got to Q. Don't forget that our Q equals to IT, which is AT. Did that before. Now be AT over, what's our V here? That's M L squared T raised power minus 3 A raised power minus 1. From here, A will go up. We have A already at the top. It goes up, turn to, we have 1 here, plus. Another one goes up, goes plus 1. Is that okay? Minus will be minus 1, which is plus 1. T1, where minus times minus will give you plus 3. Do you understand? Minus the first one, minus times minus give you plus 1. It comes up. Minus times another minus 3 plus 3. You now bring M will be up, is 1 over M. But when it goes up, it becomes M minus 1. Comes M minus 1. M minus 1. L will go up, turn to L raised power minus 2. But it's positive before, when you raise it up, plus when you have 1 over L squared will be L raised power minus 2. When you remove the 1, the same thing with others. 1 over M, when you take it up, become M raised power minus 1. In indices, now becomes A squared T raised power 4 M raised power minus 1 L raised power minus 2. This is dimension for capacitance C. This is the end of our class. Please subscribe to my channel so that I can have updates. Thank you. Have a nice day.